Okay, let's see today's 900 rated question. This is related to bit masking, right? This is a difficult question to understand. That means to find the solution, it takes quite of brain power. But yeah, we'll be able to solve it. So let's start. The question says that you have been given a sequence A of length n and you can perform any number of operations. The operation can be performed any number of times. What does each operation do? In each operation we can select an L and an R. Okay, the positions, these are the positions, and for all indexes from 0 to R minus L, replace this number with this number. Okay, so I'll tell you what that means. It means that let's say this is an array A1, A2, A3, A4, A5, A6. Okay, and we select an L and an R. Let's say we select L as 3 and R as 5. So in this case we need to replace A of L plus I with A of L plus I and A of R minus I. Okay, we need to perform this bitwise operation, and the value we need to replace whatever this value comes. And for each index I, and I ranges from 0 to R minus L. So in this case we'll see the ranges, right? I goes from 0 to R minus L. That means we need to replace which all elements. Let's say I is equal to 0. For that we'll need to replace A of L, and till A of till I becomes R minus L. So when we put this value here, it will become A of R. So we'll replace all the values from A of L to A of R, and the corresponding value with which we'll replace it with is, let's say A of L is replaced with, in this case, as I equals to 0, we'll put I equals to 0 here and here, and the value becomes A of L and A of R. Okay, and likewise it will continue, and again this will become A of R and with A of L. That means in this array what happens is that the elements A1, A2 remains as it is. As our L is 3 and R is 5, we will replace this number with by ANDing it with the last number. So if this is the part we are changing, we will AND it with the palindrome of this, that is A5, A4, A3. As we are changing this region only because L is 3 and R is 5, we will AND it with its palindrome, that is we'll switch around the numbers, as this will remain here as it is, and we'll AND it here and replace it. So this will become A3 and A5. This one will become A4 and A4. Here the number, instead of A5 it will be A5 and A3. So this is what an operation does. Okay, got it? Okay, so you can do any number of operations. Now we want to minimize the maximum value in the sequence, and you can perform any number of operations. So we'll be given a sequence, and in this sequence we can perform any number of these such operations, and we need to find the value, the minimum value of the maximum value. Got it? That means we need to minimize the maximum value present in this sequence. Let's say the maximum value present in this sequence was 3. So we should make sure that the maximum value should be 3. It should not be greater than 3. That is minimum 3 it should be. We need to minimize the value. Okay, we need to minimize the maximum value. Okay, so let's start with the problem. So let's say in an arbitrary array, right? we'll take an arbitrary array a1, a2, a3, a4, a5 and a6. Let's say I choose a number 4, right? The fourth position, a4. I choose a number a4. Using an operation, what flexibility do I have? That means what all I can do with this, okay? With fixing this element, we need to, in questions we need to fix a certain, we'll assume a certain arbitrary values and we'll perform what all we can do, right? So we'll choose a4, let's say. So if we want to AND it with a1, what can we do? We can choose this as L, this as R. So on switching the values, this will, that means it will be palindrome. So a4, a3, a2, a1. So here we can AND it, right? So the values will be a1 and a4, here a2 and a3, a3 and a2, a4 and a1, right? So what we did was, we wanted a4 to AND with a1, right? So we chose this as Lth position, this as Rth position, and this was made possible. Let's say we need to AND it with this element. We need to AND this fourth position element with second position element. Likewise, we can choose this as L and this as R. So in each operation, this means the flexibility we have is that for each element we can AND it with any element, right? As we can perform any number of operations, we can perform each operation for each L and R. So we can AND this element a4 with any element present in the array. This is what we have deduced, okay? Now we have found out what all flexibility do we have. Okay, now let's say what the question is asking us, right? That we need to minimize the maximum value in the sequence. We need to minimize the maximum value. Okay, so what does an AND operator do? Let's see. Let's say we are a number A, a number B, and we do A and B. So 1 1 0 0 1 0 1 0. So when we AND two bits, what happens is that if both are present, if both are on, then it will print out. If any one is also 0, it will print 0. What that means is that if and only if there is 1 present in both the places, then the switch is turned on. In all other cases, it is 0. So what that means for a number, okay, let's say there's a number 6, the binary representation of 6 is 110, right? And a number, let's say 3, its representation is 010. When we AND 6 and 3, what do we get? So 0 0 0 0 1 1 will become 1, 1 and 0 will become 0. So this is the output, that is 2, right? 2. What happened is that wherever there was a presence of that means both were 1, the output was same, right? 1. But anywhere if there is a 0 present, it transforms into 0. And what does a 0 mean? This is, what is this? The binary representation says that this is 2 to the power 0, this is number of 2 to the powers 1, this is the number of 2 to the powers 1, right? Sorry, 2. So when there is 0, that means there is absence of a number that is 2 to the power 1. So for that means in a number, in any number, let's say the number is capital X. A capital X is comprised of bits. Let's say the bits, individual bits are here X position X4, X3, X2, X1, right? These are the individual bits I'm saying, X3, X2, X1. So this individual bits mean that this is the presence of power of 2 to the power 4. For here it is power 2 to the power 3. Here it is 2 to the power 2 and all, right? Let me add the x0 thing. So okay, so whenever there is 0, that means the number is not there. We are reducing it. That means if there is no presence of 2 to the power 3th element, then surely the number x will be lesser than when there was 1 present here. That means what I'm saying is, if there was 1 here and if there was 0 here, right? So if there is 1 here, and let's say there's this number is x of a, case a, right? This is case a when the third bit is 1, and let the number be xb when the third bit is set to 0 and all the other rest bits are same in this case, right? So surely we can say that this number will be greater than this number, right? Because it will be like x of a plus 2 to the power 3, because this is third bit. You're getting what I'm saying? Okay. So when we do an AND operation, if there are both number present, then only the plug is switched to 1. Else the plug is switched to 0. That means the number gets reduced. What we can say is that when we AND two numbers, let's say we ANDed 6 and 3, it will result in this case it was 2. What I mean to say is that this number, the output will always be less than or equal to the individual numbers. So when we AND two numbers in a general way, a and b is equal to c, let's say this is the answer. So we can definitely say that c will be less than equal to a, and also c will be, this is not comparison, we are making statements here, and c is also less than equal to b. Why? Because if there was 1 present at both of them, then only it will get turned on. If any one of them was 1, then it gets reduced, right? So this is what the conclusion is, that the result of the operation AND will always be less than equal to the individual numbers. Now what we need to do, the question asked us to minimize the maximum value in the sequence, right? So in a sequence, okay, we need to minimize the maximum value. Let's say the answer will do the method where we assume the answer and then work backwards from there. So let's say the answer was x, that is the minimum that the maximum value can be. That means the maximum value in this sequence is x, and there is no way that we can find a maximum value that is less than x. Got it? That means x, for example, in a sequence, let's say there was 4 is the value, x equals to 4. That means 4 is the maximum value in the sequence. All the numbers a1, a2, a3, a4 are less than 4. Okay, this is the maximum value in the sequence according to the statement, and this value 4 is also the minimum we can get. That means the maximum value cannot be lesser than 4. So when we perform any number of operations from now here on, it can never get even lesser than 4. Okay, and what does an operation do? An operation adds two numbers and with another number, let's say, and what this results in, a number that is less than the individual elements. So what that means is that, let's say the binary representation of 4, right? So 4's binary representation is 1 0 0. That means if we add it with any number, I'll represent it with bits only, any number, right? When I add it with any number, there is no way that it is getting even more minimized. This is the minimum value. So if this does not get even more minimized, that means each bit, each turned on bit is staying turned on, right? It is not getting reduced. What does reduce mean? That a bit gets transformed into zero. What I said here. I think I erased it. No, it's here. Just a second. Where did this go? Okay, let it be. I'll tell you later. So what I was saying was, when we AND it with any number, there is no way that this number 4 is even getting even more reduced. Okay, so that means all the turned on bits are staying turned on, and all the turned off bits are staying turned off. Okay, and we can AND it with any element, right? So that means that this x1 should be 1, and here the x1 can be any number. The x number we took can be any number, right? Because we can do any number of operations. So that means in all the numbers that are present in the sequence, the third bit, or the first bit in this case, the first bit should be equal to 1. Let's say this was a1, a2, a3, a4, a5, and these are the bits x1, x2 and x3. Let's say, so this means that every first bit should be 1, and any other element, this all others can be anything because it was 0, right? So it should not be all 1, but it can be anything like 0 1 1 1 0 0 1 0 and 0 1. Let's say that is, this was the number a1 is the number 5, this is the number 4 6 7, this is the number 4, this is the number 6, and this is the number 5. So these are in this example the array is 5 7 4 6 and 5, and the answer is, the x for this is 4, because when we AND all the elements, the only positive bit everywhere, the only one turned on bit is the first bit, so it will be 1 here 0 0. Now you can see that when we AND it with any other element, 1 0 0, if we AND it with any other element present here, still the answer will be equal to 0, sorry, equal to the 4 number itself. We cannot go even minimum than this. When we do AND, we go minimum, right? When we do A and B, the answer C will be less than equal to both A and B, right? So when we AND, the answer gets reduced than the individual element. But when we find AND of all elements, that number will not get even more reduced. I'm not able to get it intuitively how to explain it to you all, but I think you have gotten the gist. So the answer is that, okay, I'll try another way, okay, to explain it. I'll try another way in this area. So when we do AND, the number gets reduced, right? So A and B, the answer is C. So this output C will be less than equal to A, and this C will be less than equal to B, right? At least this, I think you have gotten this statement, right? Okay. Okay, I'll explain it again, okay, don't worry, I'll explain this. So let's say there was this A number bit which was 1 1 0 1, and this B was 0 1 1 0, and let's add another 0, okay, and we add this A and B. So what happens is that each one in this element will either get, so what happens is that each one will get transformed into either 1 or 0. Let's say this is the 8th bit, right? The bit in A is 1, and if the bit in B is also 1, then the bit at C will be 1. Let's say the bit at B is equal to 0, then the C at bit will become 0. So this is the case, right? When both A and Bth bit are 1, the Cth bit will be 1. Or else, if Ath bit is 1 and Bth bit is 0, then the Cth bit will be 0. That means ones get transformed to either 1 or 0 depending on the case. But let's say the Ath bit was 0. There is no way, right? Even if Bth bit equals to 1 and Bth bit equals to 0, in both the cases the output, the Cth bit, is 0 only. That means a 0 cannot be transformed into 1. A 0 remains 0, but a 1 can get transformed into either 1 or 0 depending on the other bit. And what this means is that a number either remains same, that is 1 remains 1, or it gets transformed into 0, that means it gets reduced. The 1 gets reduced to 0. This is a greater number, this is a lesser number, it gets reduced. So for each bit, when we AND, it either stays the same, in this case this is same, or it gets reduced. In this case, in this case, in this case, it gets reduced. So it becomes 0, 0, 0, and a 0 always remains 0, right? So that is it. That means this output is the reduced form of this. It will be less than equal to this and also less than equal to this. When we AND a number, it gets reduced. So what we need to do is minimize the value, right? There is a max value, okay, a term called max value in a sequence. Max value, let's say that is for a arbitrary a5. A fifth element is the max value. The question asks us to minimize this. We need to minimize this. And what does AND do? It minimizes. So what we'll do is we'll AND the maximum value with everything, with whatever possible. So there are all these elements: a1, a2, a3, a4, a5, and we AND, and I said that a5 is the maximum value, right? So what we'll do is we'll AND every element. We'll AND this and we'll AND all this, and it will become the minimum value it can become, because I have ANDed it with all the possible cases. So that's the answer, that we need to AND everything, and that is the answer. So what the solution is, that AND everything. Oh, what happened? Just a second. 1559A, right? Oh, my Wi-Fi is not connected. Just a second, guys. But okay, I think I've gotten the gist of it. Just a minute, I'll turn on the hotspot. So sorry for the inconvenience. Just a minute, guys. You can skip forward in the video. Okay, so let's see the solution. My god, this site is so slow. Okay, so what we are doing is we'll iterating through the loop, and we are ANDing everything. I didn't get the for the first time that we need to, that ANDing makes the minimum, right? When we AND two numbers, it will be less than equal to the individual elements. So there is no need of using the math.min. We can directly say that min is equal to AND of minimum and this. So the answer is we'll AND everything. Okay, we need to AND everything. That's the answer. The code is a bit different. You can use anything you want, but the logic is that we need to AND all the elements, and that will be the answer, because that will be the maximum value, the minimum that the maximum value can get. That is, we have minimized the maximum value in the sequence. Okay, thank you.